If you manage a high throughput smart factory, your primary metric isn't just cyber risk, it's OEE, yield, and unrecoverable downtime. In modern manufacturing, we are pushing massive amounts of shop floor data into cloud AI, MES, and predictive maintenance engines. But here is the operational reality. When you connect enterprise IT networks directly to a production floor without strict architectural isolation, you create a direct highway for IT layer disruption to halt physical machines. Today, we are walking through the Purdue Model architecture, specifically designed for plant leadership. We will look at how to protect sub 10 milliseconds control loop on the shop floor while keeping your Industry 4.0 analytics fully fed. As a plant manager, you know that IT and OT operate under entirely different physical laws. Enterprise IT traffic is bursty, non deterministic, and latency tolerant. If an IT server drops a data packet or pauses for a few seconds during a software update, nobody notices. On your shop floor, it's the exact opposite. Your PLCs, variable frequency drives, and robotic controllers rely on deterministic cyclic IO updates every 2 to 10 milliseconds. If a network packet get delayed or dropped because of an IT broadcast storm, a safety PLC doesn't wait. It trips and your entire line goes into dark. In a high-speed automotive, battery, or discrete manufacturing plant, a 10-minute network halt isn't just an IT ticket. It is over $100,000 in lost throughput that you can never recover. To prevent IT traffic from impacting physical production, global manufacturing leaders rely on the Purdue model hierarchy. At level 0 and 1, you have your physical process, sensors, actuators, motion controllers, and safety PLCs executing real time control. At level 2 and 3, you have supervisory, HMIs, SCADA, master servers, and your MES driving plant execution. At level 4 and level 5, you have enterprise ERP systems like your SAP, corporate email, and cloud analytics. The most critical asset on this entire slide is level 3.5, the industrial DMZ or demilitarized zone. Level 3.5 acts as a non negotiable firewall boundary. Its job is simple: ensure that no direct IP connection ever exists between enterprise IT at level 4 and physical shop floor controls at level 3 and below. Let's talk about a scenario that happens on plant floors every single week. An enterprise IT team operating with best intentions deploys an active vulnerability scanner like Nmap or Qualys across the corporate network. If your network is flat, those IT scan packets travel straight down to the shop floor. Enterprise IT servers can handle thousands of network requests per second. But a legacy level 1 PLC or HMI network card is built with microcontrollers, designed only for lightweight deterministic industrial traffic. When an IT scanner hits that PLC with a flood of unexpected TCP packets, the PLC communication card overloads and hits 100% CPU capacity. The motion controller misses its 5 millisecond heartbeat, the safety PLC triggers an emergency stops, and your automated cell freezes. No malware was involved, just an IT tool crashing an unsegmented OT device. So, how do we fix this without cutting off the data your executive team needs for digital transformation? You enforce four strict architectural rules in your level 3.5 industrial DMZ. First, zero direct IP connection. No corporate laptop or server is ever allowed to query a SCADA host or a PLC directly. All traffic must terminate at a proxy layer inside the DMZ. Your primary historian sits inside OT at a level 3. A secondary replica sits in level 3.5. When corporate analysts run SQL queries, they hit the DMZ replica, never your production database. MFA gated PAM jump hosts. OEM vendor needing remote access to troubleshoot a machine cannot VPN directly to the PLC. They must authenticate through a multi factor jump hosts inside the DMZ with full session recording. And the fourth one is hardware data diodes. For cloud based AI engines, we deploy physical data diodes that allow data to flow out of the cloud but physically block any network packets from coming back in. Beyond isolating IT from OT, we must also isolate different areas of the plant floor from each other using ISA 62443 zones and conduits. In a flat OT network, if a maintenance laptop with malware plugs into a switch in the stamping area, the malware moves laterally across the network into paint, assembly, and packaging in minutes. Under ISA IEC 62443, we group equipments into isolated security zones. For instance, stamping cell 1 is its own zone, paint line is another. Another traffic or the network traffic between zone must travel through defined conduits governed by next generation firewalls with deep packet inspection. If a network anomaly or broadcast storm occurs in cell 1, the firewall blocks it at the conduit boundary, keeping the rest of your factory running at full capacity. So, if you are a manufacturing team, a plant manager, or an operation director working with your team looking at your facility today, here is the immediate four-step action plan to take back control of your operational risk. First, audit your boundary matrix. Audit every firewall, dual home, NIC, and unauthorized cellular 4G or 5G modem, bridging your plant floor to corporate IT. Second, enforce level 3.5 DMZ isolation. Mandate that all MES, SCADA, and historian data sharing passes strictly through proxy layers in the DMZ. Third, deploy passive OT asset discovery. Ban active IT scanning tools from your OT subnets immediately. Replace them with passive network TAP slash SPAN monitoring tools that discover assets without sending a single active packet to a PLC. Establish ISA IEC 62443 governance. Define clear target security levels SL1 through SL4 for every operational zone across your facility. Securing a modern, highly automated factory is about bridging the gap between high level corporate cybersecurity mandates and the real world sub 10 millisecond shop floor engineering. At ACH Solution, we specialize in conducting comprehensive IT OT boundary audits, Purdue Model validation, and ISA 62443 readiness assessments, tailored specifically for high throughput manufacturing environments. To evaluate your plant's network segmentation or design a zero downtime level 3.5 DMZ architecture, reach out to our engineering team at services@achsol.com. And for ongoing strategic framework on industrial cybersecurity, subscribe to the CyberWise Tech channel. Thank you.